Right, hi everybody, good morning, afternoon, or good evening. Welcome back. In this video, I want to move on to topic 5.3, which is called Soil Degradation and Conservation. And it's pretty much the end of topic 5, Soil Systems and Terrestrial Food Production Systems and Societies. Obviously, we can approach this in two sections. One is to discuss soil degradation. Soil degradation is the reduction in fertility of soil. And I've given you the four main things that I'll go through in terms of how that happens: urbanization, overgrazing by animals, deforestation, and mismanagement of land or farmland. Then conservation. Obviously, conservation involves avoiding those four things. So therefore, erosion, salinization, and nutrient levels, well, they are things that result from mismanagement of land. So we can talk about how we avoid that. And then how we prevent overgrazing, and how we prevent soil compaction. Soil compaction is obviously just when soil becomes squashed, the particles get squashed together, and therefore soil loses its texture and its permeability, the ability of water to flow through the soil. So therefore it becomes infertile. So I hope that made sense. I'll try and go through it fairly quickly, but there's quite a lot to get through. Let's take a look at the syllabus first of all. So the syllabus first of all says soil ecosystems change through succession. I hope that you can remember when we looked at topic 2, we looked at the idea of succession. Succession is where new soil is formed, either from scratch or from existing soil. And succession is the process of new communities coming in and colonizing that soil, new communities replacing them, new communities, and so on, until we reach a final stable community, which is called a climax community. Now, humans are very good at interrupting that process, and when we do that, it's called a plagioclimax, an interruption of the process of succession. In order to reach healthy soil, or the most healthy soil, we should allow succession to continue, but we interfere with the process and we stop it at certain points. So therefore we affect soil fertility. Fertile soil contains a community of organisms that work together to maintain a functioning nutrient cycle, and also makes the soil resistant to soil erosion. So without these communities present in full in the soil, we have issues with the nitrogen cycle and the carbon cycle, breaking down of detritus, breaking down of dead material, and so on. And therefore that's why a lot of farmers, especially in commercial intensive farms, become very dependent on artificial fertilizers. Okay, number 2, human activities can reduce soil fertility, and they include deforestation, overgrazing or intensive grazing, urbanization, and agricultural practices. That's pretty much what I've said above, except I talked in terms of land and mismanagement rather than problems with certain agricultural practices. We'll go into some detail in a minute. Commercial industrialized food production systems generally reduce soil fertility more than small-scale subsistence farming methods. So in terms of maintaining soil, intensive agriculture is normally a bad thing, or it produces problems with keeping the soil fertile. Reduced soil fertility results in soil erosion. Soil erosion is not just the breakdown of the soil texture and soil structure, but erosion by definition involves moving the soil from one place to another place. And that occurs by water erosion or wind erosion. So in order to keep the soil fertile, you have to reduce the process of erosion. Reduced soil fertility also results in toxification, the soil becoming toxic, salinization, the soil becoming over salty and therefore not being able to support communities, and desertification. Well, desertification is obviously the formation of desert, which results from very, very excessive erosion or the loss of soil completely. And then finally, soil conservation measures include adding chemicals which are referred to as soil conditioners. That very often involves changing the pH of the soil if it becomes too acidic or too alkaline. Techniques to prevent wind erosion. That can be as simple as building windbreaks or lines of trees to prevent the wind moving across the land and taking soil with it. Changing cultivation techniques, terracing, which means flattening the land rather than farming on slopes. Contour ploughing, we'll talk about that elsewhere. Strip cultivation is the technique of planting crops in strips but alternating the types of crops that you grow. So in other words, avoiding excessive monoculture. And then it says here, avoiding the use of marginal lands. Well, very often that's referred to as building buffer zones around farmland. And buffer zones are strips of uncultivated land which you don't farm, but which gives corridors for organisms to move around, including animals. It's soil that's uncultivated, so it retains its initial nutrient quality. And also, these buffer zones can act as barriers to erosion, wind and water erosion. Okay, hope that made sense. And then finally it says, under applications and skills, we need to explain the relationship between soil ecosystem succession and soil fertility. Well, we talked about it in topic 2, but I'll leave that to the classroom, I think. And we need to discuss the influence of human activity on soil fertility and soil erosion. And we need to evaluate soil management strategies of a given commercial farming system, so intensive farming, and a given subsistence farming system. Well, my intention is to do one final video where I'll give you some fairly specific case studies about some of these things, which I think will be useful for essays. So I think we'll leave that for the case studies when we look at that separately. Okay, so I think the first question is, what is fertile soil? It will help us to identify how to conserve soil if we understand what a fertile soil actually is. So first of all, it's worth noting that soil is considered to be a non-renewable resource or a non-replenishable resource, although it does include living communities. It takes on average about 2,000 years to make 10 centimetres of soil, which is a long, long time to produce the soil that's in your garden. A good soil or a loam soil has a good texture to allow plant growth, a good balance of large particles, small particles, and intermediate particles. We talked about that in topic 5.1. It has a good soil community of fungi, bacteria, microorganisms, and macroorganisms to help to recycle nutrients in the soil. It has a good balance of nutrients, largely nitrogen, phosphorus, and potassium, NPK, a good balance of minerals, and a suitable pH. Poor soils have very high pH or very low pH. A low pH soil is acidic and a high pH soil is basic or alkaline. The problem with these high pHs or low pHs, well, an acidic soil with a low pH, the acidity releases toxins into the soil, for example, heavy metals. And very, very high pH soils, above pH 7.5 or above pH 8, they reduce alkalinity in the soil in the form of calcium carbonate, which alters the texture of the soil and prevents water from moving through it. Very low pH soils are generally associated with clay soils as well, and clay soils have a very high proportion of very small particles which also won't allow water to percolate through. And then obviously very high pH and low pH will kill off the soil community and prevent this efficient recycling of nutrients inside the soil as well. Okay, so that's fertile soil and infertile soil. We need to look at the processes that result in infertile soils being formed. Now, an obvious thing that results in, I was going to say infertile soil, but it can lead to the loss of soil completely, is erosion. Erosion is the process, as I said before, of moving soil from one place to another place. It can be a natural process, but it can also be exacerbated or made worse by human activities. About a third of the world's soil is now considered to be degraded, and erosion is the main form of that degradation. But chemical degradation also occurs either through pollution, salinization, acidification, or nutrient depletion, and by physical degradation, which I'm going to refer to largely as compaction, squashing the particles of the soil together so it loses its texture. Very, very compacted soil, well, two problems. One is lack of water can move through the soil, and the second is lack of aeration, which is needed by plant roots to grow and by organisms to live inside the soil as well, to allow them to respire. Okay, and those activities that I referred to, well, you can already see them above my head. Urbanization, the growth of towns and cities. We concrete over soils or tarmac over them. We compact them. We drive vehicles over them. Overgrazing, allowing animals to destroy the communities of plants that live there already, to remove plant roots which hold the soil together and keep its texture. And also animals, when kept in huge herds, can also trample soil and lead to soil compaction. Deforestation, obviously. Again, a big problem there is the loss of soil roots. If we're not specifically talking about farmland, rainforests have very, very thin soils that are held together by huge swathes of plant roots. You remove the plant roots and you remove the soil. Another issue with deforestation is because especially rainforests have had so long to evolve, they take up every niche that's available, and therefore they take up most of the nutrients that are available. They're very, very efficient biomes. So therefore, if you take away the living material from a rainforest, you're taking away the nutrients, because so much of the nutrients are bound up in the living things rather than in the soil. And then again, I keep saying this, we'll come back to the idea of mismanagement, specifically of farmland. Okay, so I think I've said most of this already. Urbanization causes soil to be compacted or moved around. As we build, we tend to dig into the soil and transport it from place to place, or dump it in many cases. Uncovered soil in urban areas is compacted due to people walking over it or heavy vehicles, and very often polluted. We use soils basically as open sewers in a lot of urbanized areas. Overgrazing reduces vegetation and removes protective roots. Deforestation directly removes nutrients, I've already said. And in terms of mismanagement, well, we can go into this in a little bit more detail. If we overharvest from farmland, in intensive agriculture, you can have many harvests in a single year. And if you're taking away the plant material, you're taking away nutrients which must therefore be replaced. In intensive agriculture, that's done by artificial fertilizer addition, but it has to be done carefully. Monoculture can be responsible for removing nutrients very rapidly from soil, so therefore it makes sense to grow different crops at the same time, or at least to rotate your crops, or even to leave land fallow, which means just leaving land alone or soil alone to recover between different crops being planted. Monoculture leads to huge pieces of land being open to the elements, open to wind and water, and therefore very vulnerable to erosion. If we over-irrigate, if we add too much water to farmland, that can lead to the buildup of salts that are inside the water building up into the soil. If the soil becomes too salty, or the correct word is salinized, then it becomes infertile. It's too salty to support plants and animals in the soil. Pollution, often by addition of things like pesticides, can also affect the soil community. We talked about that in topic 5.2, overuse of pesticides. As less and less land or good land becomes available for agriculture, many farmers are forced to use sloping land, or very, very sloping land, which can be very vulnerable to water erosion and wind erosion, especially water as water runs down slopes. is the loss of soil. And then finally, similar thing actually, if the more and more marginal land we're forced to use to farm, the more soil we're actually using with poor characteristics. And that soil again might be very, very vulnerable to erosion and mismanagement. Okay. And then I said I'd mentioned the two major things which lead to massive soil degradation. That would be desertification and salinization. More and more soil around the world is becoming exhausted. And when the soil is exhausted or eroded away almost completely, it forms desert. And humans are responsible for creating huge amounts of deserts around the world. This is one example. This is the Aral Sea in Eastern Europe. We'll talk about it. Crosses a number of boundaries of countries, but we'll talk about the Aral Sea as a case study. Okay, and the more land that becomes desertified or salinized, the more and more difficult it becomes to reverse that process. So the soil can basically be lost forever. Okay, so I think I've covered everything I wanted to cover in terms of degradation. I hope you could follow that information. I kind of threw quite a lot of things at you very quickly. So let's move on to conservation. So in many cases, it's just a case of preventing or stopping these processes of degradation. In many cases, that just involves keeping humans away from the land in the first place. But in terms of reducing erosion of farmland, well, number one, farmers can build windbreaks. Very often those are lines of trees or shrubs, as you can see here, that prevent winds moving across very, very open pieces of land. The other thing that they provide is corridors for different species to move around. And also it's an area of uncultivated land, as I said before, that's basically a buffer zone that allows nutrients to spread from there and allows communities of animals and plants to grow separately to the farmland. Other techniques, well, we'll talk about this separately. Conservation tillage. Tillage is another word for ploughing. So it means not over ploughing the land. Providing vegetation cover, perhaps leaving land fallow between crops, and these buffer zones that I've already mentioned that are between pieces of farmland. They can also act to conserve soil structure and prevent wind and water just moving unstopped or unchecked across large pieces of land. Remember in topic 5.2 we said that in the US I think the average size of a farm is 200 hectares, which are huge pieces of land, very often with no breaks between them. No wind breaks and no water breaks and no buffer zones. Reducing salinization. Well, I already said salinization is caused by overwatering or over-irrigation. So water should be used carefully on land and shouldn't be overwatered. That can involve not watering at specific times of the day, especially very, very hot climates or places close to the equator, because when water builds up in soil and it evaporates, the water is lost but the soil stays behind. So it could make sense to irrigate at night when it's cooler. Salinization happens when soil is compacted because water can't move through or percolate, so it could also involve other measures to prevent soil compaction. For example, not using heavy machinery or not allowing trampling of land by big herds of animals. And it could also involve flushing very clean water through at certain times to try to flush salts through the soil. Okay, in terms of nutrient levels, we're still on the idea of land mismanagement here, of preventing land mismanagement. All of those things we mentioned before about avoiding soil erosion helps nutrients to remain. We can add organic matter to soil, that's called mulching. So basically adding compost to soil and digging it in replaces nutrients. It could also involve manuring. I guess in some cases that could also extend to adding organic fertilizers carefully. Using leguminous plants, again, something we talked about elsewhere in the course. Legumes are peas and bean plants, which have symbiotic communities of bacteria in the root systems that put nitrogen back into the soil. We actually talked about that when we talked about the nitrogen cycle. So that could involve planting those as crops or planting them periodically in combination with other crops. As I've said before, careful use of synthetic fertilizers with the correct values of nitrogen, phosphorus, and potassium, so you're replacing the nutrients that are lost. Lining is adding calcium carbonate in order to increase pH to make soil less acidic. And as I said before, that helps to retain a healthy soil community. Rotating crops, so you're not sowing the same crops year in, year out. So they have different nutrient requirements, and you're also able to return nutrients to the soil. In many cases, it involves allowing grass to grow and then just ploughing the grass back in, rather than trying to get every year as many crops harvested as possible. And again, that can also involve leaving land fallow or just not doing anything with the land for a year or a couple of years. Polyculture. It's possible to switch from monoculture to polyculture. Many indigenous communities were much wiser about this than modern farmers, I think. For example, the Maya in southern Mexico were very aware that when they farmed land, they produced polycultures, which they called milpas, which you might be familiar with. So it involves growing beans, maize, all the crops together at the same time in order to not exhaust the nutrients and allow nutrients to be replaced. Obviously, the use of bean plants is very important because they are leguminous plants that return nitrogen to the soil. Okay, so I think I've covered land management there. Fairly obvious, just to come to the end of this video. Preventing overgrazing, keeping herd sizes as small as possible, I guess, in terms of the land that's available. Simple techniques involve maybe fencing the animals in one part, allowing them to graze, and then moving them along, so that you're only allowing one piece of land to become compacted at one time, and then you can deal with that compaction. So maybe moving animals, herds around your land, not allowing big areas of land to be completely stripped of vegetation all at once, making sure there are some buffer zones, using fertilizers properly to allow vegetation to regrow, and again, coming back to what we said before, allowing buffer zones and windbreaks to grow in order to prevent erosion as well as compaction. Once the soil is compacted, it's very vulnerable to erosion, becomes very dusty. We'll talk about that. That's one of the problems with the Dust Bowl problem in the 1930s in the US. So again, we'll come back to some specific examples or case studies of that in my final video for topic 5. All right, and then just to conclude, preventing soil compaction, it's linked back to what I said before, reducing herd sizes, not allowing big pieces of land to be trampled at the same time, trying to reduce urbanization. Well, that's possibly easier said than done, because there are huge social costs to not allowing urbanization to continue. And one last topic that I just thought of just before I start recording this. It is quite important to make sure that when people are allowed to walk over land, they keep to footpaths. So in terms of national parks, farmland as well, that you don't allow people to just walk wherever they want, and you try to keep people to trails to make sure that only the trails are compacted, not the wider pieces of land. Okay, so I realise possibly another rambling one, but there's quite a few ideas there that I think you could take note of, possibly put into a better format than I've managed to do in this talk. Okay, well, thanks for your attention, everybody. Speak to you in the class, and we're just about completed with topic 5 now. As I said, maybe just one more video where we can introduce some quite specific case studies that will be useful in essay questions. Okay, bye everybody. I'll speak to you in our class.